Hey, Pre-Algebra, Mrs. Ratzberg here. So today we are talking about problem 1.3, looking for squares. And our focus question today is, how are square roots and squaring related? So first off, we're going to do a couple of definitions, and the first is the word exponent. And the exponent is, so the exponent of a number says how many times so the exponent of a number says how many times to multiply the base by itself. Okay, and then a square root is a value that, when multiplied by itself, gives the number. And that's going to make a heck of a lot more sense in a little bit. Okay, so the area of a square is the length of the side multiplied by itself. This can be expressed by the formula A equals S times S, or A equals S squared. And what they mean by that, so I'm going to draw just like a square here. Here's S, here's S, here's A. So to find the area, you would just multiply S times S, which is what you see right here. But when you see S times S, that's the same thing as S squared. Okay, so if you know the area of the square, so if you knew A, you can work backwards to find the length of a side. For example, suppose a square had an area of 4 square units. So let me erase this A. Nope, not yellow, that's a bad idea. And write 4. To find the length of a side, you need to figure out what positive number multiplied by itself equals 4. And so because 2 times 2 equals 4, the side length would be 2. And so this number 2 is called a square root. In general, if A equals S squared, then S is a square root of A. So because 2 times 2 equals 4 and negative 2 times negative 2 equals 4, technically both 2 and negative 2 are both square roots of 4. Every positive number has always 2 square roots, and the number 0 is the only one that has just the 1 square root of 0. However, in most cases this year, actually in all cases this year, the only square root that we care about is this positive square root, because most of the time we're going to be focusing on it in terms of side lengths, just like how we had this square. You can't have a negative distance or a negative side length value. That doesn't make any sense. So just know that generally speaking this year, we're only going to have positive side lengths, but as you move into algebra next year, you will definitely have both positive and negative side lengths. Okay, so for any, so here's like the algebra talk of it. For any positive number, the square root of n, so this symbol right here means the square root. Let me draw it as well. So you kind of do, it's like a division sign, but it has like a tail in the front. So I draw that. Whoa, I held it on too long in Notability, thought I was making a line. So I make a kind of tail, and then I make the division sign. So the square root of n indicates the positive square root of n. For example, the square root of 4 equals 2, and that's how you say this statement right here. The square root of 4 equals 2. And the negative square root of 4 is negative square root of 4, which equals negative 2. Okay, so what is the side length of a square with an area of 2 square units? Well, generally speaking, if you're given the area of a square, the side length would be then the square root of 2. And then the next question says, is the length greater than 1? Is it greater than 2? Well, let's think about it. If it's greater than 1, that means it has to be bigger than 1 times 1. Well, 1 times 1 equals 1. So it's definitely bigger than 1, so we can say greater than 1. But then is it greater than 2? 2 times 2 is 4, and that's bigger than that 2 inside my square root symbol, so it's less than 2. And then these next two questions we're really not going to get into yet because that's going to be another lesson. Our focus today is really just understanding square roots in terms of nice, kind numbers for the most part. All right? So answer the following questions. Find the side lengths of squares with areas of 1, 9, 16, and 25 square units. So I like to actually draw squares because then you can really visualize, and then I don't know, something in your brain changes when you think about it in terms of area. So what times what is going to equal 1? Yeah, 1. So that means the side lengths are 1. What times what is going to equal 9? Yeah, 3. What times what equals 16? 4. Good. And what times what equals 25? 5. Okay, so now we're going to take away that scaffolded piece of the area of squares, and we're just going to go right into, well, what's the square root of these? So I'm just going to write those first. So square root of 1, square root of 9, square root of 16, square root of 25. And then we already know the answers. We just did that. So the square root of 1 is 1. That's the easy one. The square root of 9 is 3. The square root of 16 is 4, and the square root of 25 is 5. You can even think of it as you're seeing kind of a square as that radical symbol. That the radical is the same thing as the square root symbol. So know that. Okay, moving on. So answer the following questions in part B. What is the area of a square with a side length of 12 units? So some helpful things, let's draw a picture. So side lengths of 12 units, so that means 12 and 12. Well, to find that area, we would have to do 12 times 12. That's 144. So 144 units squared. You also could have thought of it as 12 squared equals 144. Okay, and then what is the area of a square with a side length of 2.5 units? So again, you can draw your square, label your sides, and say, oh yeah, no, I just have to do 2.5 times 2.5. Or 2.5 squared. And I don't know this one, and this is, remember, a no calculator investigation unless the instructions say to use it. So 5 times 5 is 25, regroup. 5 times 2 is 10, plus 2 is 12, so 12 tens. 0, 2 times 5, cross that out. 2 times 5 is 10. Regroup that 1. 2 times 2 is 4, plus 1 is 5. And then that's about 2 times 2 is 4, so my decimal should go here. So that means the area would be 6.25 units squared. Okay. So then, number 3 says fill in the missing blank. So we have the square root symbol with a blank under it equals 12. So what they're really looking for here is what's the area? And we found that, right? We found it that it was 144. So you would just put a 144 under there. All right. And then B, the square root symbol. So what is the area with a side length of 2.5? And we found that was 6.25. Okay. So with part 4, it says solve for x. The way that so we see x squared equals 121. So to find just one x, we need to undo that squaring. And to undo that squaring, you're going to just take the square root of each thing. So then you think, now we have this radical, this number under this square root symbol. So that means that this 121 is our area. So our area of our square is 121. So then what number can we multiply by itself to get 121? 11. So x equals 11. Okay, So then part B, x squared equals 1.44. So again, we have to think, this is saying, well, this is my area right here of this 1.44. I need to take the square root of both sides. And then I know that 12 times 12 is 144. So that means my x must be 1.2, because when we think about if we actually did that multiplying, 1.2 times 1.2, we get that. So when we see decimals, we just have to think, well, where would the decimal go in the original, and think about placement of decimals, okay? So next we have the square root of x equals 11. So we can think of this in a couple of ways. First, we could think, well, this x right here, that represents area. So, and the 11 represents side length. So if my side lengths are 11, what would be my area? Another way you can think about it as an equation, and you could say, well, I see a square root. I don't want a square root. I want to undo a square root. So I'm going to square both sides. So x equals 121. All right, and then D, actually, there's very little work. There's minimal work to do because the x isn't squared. So we're told, again, that this 1.44 is our area, which is exactly what we were told in part B, which means x would equal 1.2. Okay, so go ahead and take a minute and try, and with all those times I've mentioned, side lengths, area, go ahead and try and fill in. So I'm going to kind of do some blanks to scaffold. So blank squared equals blank, and the square root of blank equals blank. So go ahead and think about what could go in those blanks. Like, what does that mean? Okay, we're back. So this blank squared equals blank. Our area would go here, and the equals just a number. But then what we're squaring is our side length. And then in the next line, when we take the square root, we're finding the area, and that equals our side length. I probably gave the answers away a little bit by my long lines. Okay, so finally, focus question. How are square roots and squaring related? And it's a pretty simplistic, it's just another tool in your toolbox of solving equations. Squaring is the inverse of square roots. And we kind of, we didn't see this last year because we skipped that. If you were at Tri-North last year, because we just ran out of time, but we would have also used this inverse relationship to find the radius of a circle given the area, but we skipped it. We'll come back to it, maybe. We'll find out. Okay, so next you have daily practice to do. Make sure you ask your pre-algebra teacher if you have any questions. If not, have a great day, guys. And if you do have questions, have a great day. Have a great day.